Thank you. Can you see my screen?
Yes, we can. Thank you very much. Very clear.
Okay, perfect. Thank you for the introduction. And indeed, today I'm going to propose to you one of our proposals on the microalloying of vanadium in high-strength, low-alloyed steels. This specifically for targeting a higher strength within this steel group, which is currently an ongoing project with different tracks on how to increase the strength. And we are now focusing, or we want to focus on microalloying with vanadium, besides another track in a larger framework where we are also looking at microalloying with other elements. So for this specifically with the vanadium, we plan on targeting a semi-recrystallized microstructure and in that way achieving higher strength levels, specifically above 550 MPa. And besides this product development, we also want to gain more knowledge and understanding of the way the vanadium and the precipitation of vanadium during annealing after cold rolling affects then the final properties of these steels. And we want to do that, in fact, by using artificial intelligence tools linked with digital image analysis and prediction software to be more objective in the way that data is processed, and maybe also see correlations that we did not think about in advance. So this is why I'm going to, this proposal is on the table. Now, what is the reasoning and the background of this? For the cold rolled steel, it is, as already mentioned, annealed afterwards to get normally a fully recrystallized microstructure, but we want to target more complex microstructures. Sorry?
This is the last talk.
Sorry. Towards higher strength levels with then, of course, resulting a little bit of ductility. Microalloying specifically delays recrystallization onset, and hence the resulting microstructure are partially recrystallized. However, the understanding of how this is linked with the process parameters and how stringent these must be in an industrial trial is what we are interested in, and so that's what we want to study within this proposal. How are we going to do that? We're going to make 3 different compositions with varying vanadium and carbon to then influence the precipitation during subsequent processing steps like hot rolling, cold rolling, and annealing, where we will vary different parameters and thus obtaining a large set of different materials, where then from those materials different data will be collected. So not only microstructural images, but mechanical properties through tensile testing will also be gathered, and the precipitation states through ICP-MS will also be, so the fraction of precipitates will also be studied. And this collection of data, which will be 2D and 3D data, will then be analyzed by means of the tools mentioned with the artificial intelligence. So we have a more objective evaluation of the data that we collected on these different types of materials with then the varying compositions and processing steps. And with this large data set and the way we are handling it, we want to obtain we want to see which correlations can be made to link the process, the structure, and the property of these specific materials to then see if we can obtain those higher strength levels. In fact, through also classification tools within the digital image analysis and prediction software, which can then cluster similar materials, but also maybe separate different ones, where maybe with a human approach, this would be more tricky to incorporate all the data and features that we can collect from the experimental data. So with that approach, there we can maybe also summarize then the relevance and the application field for this specific project. So it's targeted, as mentioned, product development for high strength low alloy steels microloid, but also ultra high strength low alloy steels, which then can be used within racking structural applications or silos, or maybe even solar applications. We envision this project to be a 2.5-year project with a request of funding of $150,000 for the Vanitech, where with the artificial intelligence tools and the experimental data, we further then want to validate this model with a more in-depth experimental details on selection of grades with TM and atom probe to then see and understand why certain materials came out of the analysis or the digital analysis. And these results will then be shown twice a year here within this meeting to monitor the progress of this project. With some confidentiality restrictions, then mainly on the chemical composition, which will not be fully disclosed due to the project development's inherent inherency of this topic. So, as mentioned, the impact on the vanadium market or the interest here is mainly looking at precipitation during annealing after cold rolling, which is an interest of Vanitech. And the impact on vanadium market is mainly seen as if the results are positive and interesting, this will lead to industrial trials and then an upscale of the sales of the vanadium within this grades and in a future step. I also included a Gantt chart, which is indicative, and the different work plans that are envisioned. So as mentioned, first there would be a lab cost of these materials, which is foreseen in the first half of the year of 2024, after which they will be fully processed and annealed. And then a large data set of samples will be collected. We will do SEM, SEM, ICP-MS, and optical microscopy to gather information on the fraction of recrystallization, fraction of precipitation, and mechanical properties, to then be analyzed and linked and correlated in the third work package using our empirical and artificial intelligence modeling. And the reporting is ongoing over those years. So we envision an end in Q2 of 2026 on this work. So with that, actually, I am finalizing the presentation of this proposal. If there are questions, please let me know.
Thank you very much. And again, apologies for making you wait a little longer than we anticipated.
It was very interesting, so no problem.
Does anyone have any questions or comments on this proposal? I have a question. You're going to look at different combinations of vanadium and carbon and look at how that affects recovery and recrystallization. Will you be looking at different coiling temperatures because the coiling temperature will affect the state of the vanadium before it goes into the annealing state. Is that something you'll be looking at?
This will be considered, yes. It's listed in the parameter sets of to check two coiling temperatures.
Okay, thank you. Any other questions on this one?
I could just comment, I guess, since I haven't done so far in the meeting. This is Bob Ladowski. The way I understand it, what you're looking at is looking at annealing response of microalloyed steels, particularly vanadium microalloyed steels. And you're going to do this with laboratory melted heats and laboratory processed heats. Is that correct?
Yes. And then if the results are promising, this will be upscaled to an industrial trial.
And there's been a lot of work done, particularly at ASPPRC about 10 years ago on this general subject. And and again, what I point out, you haven't been familiar with this, but some of the people on in this meeting are. I will point out that when you add vanadium, you have to concern yourself with nitrogen, and when you concern yourself with nitrogen, you have to look at the vanadium, at the aluminum content. And that work done 10 years ago positively identified the interaction of aluminum and vanadium during the annealing cycle, although it was not well quantified, which would be great if somebody could do that. But I would just suggest you make sure you have that. I cannot envision you having enough lab materials to fully develop an AI model of what's going on and getting both processing and chemistry effects into play. I could be wrong, but I just would be very concerned about that.
Well, so indeed, as mentioned, this fits within a larger framework of studying microalloying. So we are actually envisioning making much more materials with other elements to microalloy this type of material with. And then the model is already made and will be fine-tuned then specifically for this parameter set. But indeed, yeah, the number of materials that are being made is much more than what will be reported here. So the vanadium is actually limited set, but then the other materials will be included for the tools and the analysis and the results of that.
Okay, so your request to us is to ensure that vanadium is included as one of the variables studied.
Yes, because we think it's interesting. It's not a lot of yeah.
Okay, thanks for that comment, Bob. That's a good point. Any other questions? Okay, well, I'd just like to remind you, I'll repeat what I said to Kevin. The Vanatech directors will be meeting later in October, so I'd expect a decision late October, early November. So look forward to hearing from us then.
Thank you.
Okay, so with that, I'd like to draw the meeting to a close. I'd just like to draw your attention to the agenda, and you'll see that there are a number of Vanatech related papers which we published over the last 6 months or so. And the final item on the agenda is the 2022 Vanadium Award, which was won by Professor the Texas A&M team with Sabajit, who we've already heard from today, and some of his co-workers. So congratulations again on that award. And it will be presented in London in December. So we'll look forward to that. So again, well done to the Texas A&M team. Well done, Sabajit.
Thank you, David. Hopefully, yeah, if you have a chance, it'd be great to meet up in London. Yeah.
Hey, Sabajit, while we've got you, we got a note in the comments. Not sure if you saw that. That may have gone just to Dr. Crowder. that our Chinese members can't open up your survey because it's Google based. And
Oh.
we have a similar issue, it turns out, I didn't know this, about them being able to even see the map because the map data behind it is Google based. So let's talk about that offline. But just
Okay,
aware of that.
okay. Well, we could come up with Qualtrics or something else. That's no problem. All right, okay.
Right. Thanks.
Okay, so thanks to everyone. Thanks to all the presenters. Thanks to the audience. A great meeting. And we will get together in about 6 months' time in March 2024. So thank you very much and goodbye from the Vanatech offices near London. Thank you. Goodbye.
Bye-bye.
Bye-bye.
Bye.
Thank you. Bye.